Good morning, everybody. This is today class. We are making decisions, drastic decisions. Well, I have enough people answering the quiz, and we can talk about that later, but don't forget to answer the quiz because it's attendance. Even if you don't need attendance, I need to know who was here and I need to know what are you learning. So it's not optional. Let's make it full page. Now, making decisions. How we make decisions. We have a particular question here. What happened when this, if you have a sequence with only A and P? What happened with the GC skew? Okay, so G will be 0, C will be 0, this minus will be 0, but G will be 0 and C will be 0, so this plus will be 0. You have 0 divided by 0. So, but when you have 0 divided by 0, is not this, is essentially the result is undefined. Because essentially you are asking which number multiplied by 0 will give you 0. And anything can give you 0. So if I multiply by 10, 0 multiplied by 10 will be 0. 0 multiplied by 1 million will be 0. So it is not wrong, it's just undefined. It can be anything. So we have to make a decision. And following Zainab idea, a reasonable decision is that in this case, the GC skew is 0, because think about philosophically, like what is the difference between two things that don't exist? There's no difference. Minus means difference. You compare two things. When you take A minus B is one way of comparing two things. And the technical name from minus is difference. The difference between A and B is A minus B. This is literally the definition of difference, of minus. It's called difference. But that is why we call differential calculus, because we take the difference, the minus, between one and the immediately following. Anyway, we have therefore to make a decision, and the decision that we make is that the GC skew is 0, and it kind of makes sense. Okay. You can argue that can be something else, but for today's class, it is not very critical what is the value. The point is that we need to recognize when G plus C is 0. So if you did the homework, you could have had the bad luck that you get a gene that is only AT and T, and you get this error. We need to do something. We need to realize that this is happening. And that essentially means that we need to improve our rule to calculate the GC. We have a rule to calculate GC. That is essentially count G and C and calculate this formula. Count how many C, how many G, and have this formula. But now we need to include this condition. If the sum is 0, then the result is 0. Otherwise, the result is the formula. But this formula is valid only if this is not 0. Essentially, every time you have a division, it's okay. There are a couple of strategies here, but one strategy is that you test if the denominator is going to be 0 before doing anything. Okay, before doing the division. You see, am I going, or are we going to divide by 0? In that case, we do something before making the mistake. Otherwise, we know that this operation is fine. Okay? But in practice, how do we recognize that GC is 0? What we do? Well, if you have seen any computer code before, you will recognize this. There is, and the last tool in our toolkit. Our toolkit has essentially function, for loops, and if. These are the keywords. And literally keywords. These are not functions. The word function is not a function. These are keywords, are part of the language. So we have this keyword if. If this condition is true, then this code is executed. Okay? If not, you skip it. Okay? So if the number is less than 0, then you execute the code. Okay. In fact, in our case, we use a variant of the same thing. It's called the if then else. If this then that. No. If this then that. So if the condition is true, we do the first part. Otherwise, if the condition is false, we do the second. Only one happens. You do either the first or the second, but not both. So this is a fork or a split in the road. You get a moment that you have to decide, okay, we have two options here. What we will follow? When you test the condition and you choose either this or this, and eventually they join together. You get to the rest of the program is the same. In this part, you have a fork, a decision to make, an alternative to take. Okay, how we will update our code? Well, I guess you can imagine, but if try to imagine, and I think you will imagine something like this. This is the code that we had in the last class, in the class number 6, I think. And this is the new part. If the sum is 0, then the skew is going to be 0. No discussion. We don't do any division. We just say it is 0. It's a reasonable number. It makes sense. And in the other case, if this number is not 0, we can make any division. Then we go and we use the formula that we had before. Okay. This is the last version that we are going to have here. Okay. We take a sequence. The sequence can be a genome, a gene, or just a piece of DNA. The only condition is it has to be a vector of A, T, G, and C. In fact, not even. It has to be a vector of letters, and some of the letters are C, and some of these letters are G. If they are something else, we don't care. The only condition is that we are counting the number of C's and the number of G's. So it makes sense if it's DNA. And we are just careful that we don't get a division by 0. Okay? Remember, if you have any question, there is no stupid question. Or let's say the only stupid question is the question that you didn't ask. So it is a good practice to test your code. In fact, people who do this professionally, they have a standard procedure of testing. Like you have a series of experiments that you have to do with your code, and it has to give you the correct answer in every case. For example, if you have AT and TNT, this one is given 0, the one that we included now. If I have a 1G and 0C, you get 1. If you have 1C and 0T, you get -1. You can check your code if doing the same. Because sometimes it is easy to make the mistake and get the opposite sign. Okay, so let's make an application here. It will be very easy, and you will find it silly, but believe me, people have problem with this. In the previous classes, in the previous years, people had problem with this. Smallest two values. How you find the smallest of two values? Can you give me an example? I want to make sure that you understand this question. Tell me, dear people.
Rank from smallest to highest.
No, you have two numbers. Yeah, how you? I give you.
We can rank again.
How do you rank? But that's cheating. That is essentially ranking is finding the smallest, no?
My other idea is this: you should create a function that will not do the let's say values are A and B.
Okay.
Start A minus B and then B minus A, and we should say which one is negative.
Okay.
A minus B is negative. It's A.
It works. You are like scratching your hand like this. Instead of doing this, you are doing the complicated way. But yeah, it works. You can scratch your ear in a convoluted way. Because if you take A minus B and you compare with 0, you can compare A with B.
Oh, right. Okay, it makes more sense. Yes.
Yeah. Okay. Because the Zeynep answer is kind of tricky, because you say you order them, you rank them. But the point is that for doing that, you need to know which one is the smallest. But it's the process of sorting, and it requires you to compare things and choose which is the smallest one. And it will tell you sorting is harder than comparing. Comparing is a condition for. Okay, can you give me an example of sorting two things? If I give you two numbers, like 10 and 15, which is the smallest?
10,
How you know?
because if we say 10 minus 15, it means minus 5.
Okay. I will argue that they teach you the other way. Like they tell you the negative numbers is when the second number is bigger than the first. But okay. Okay, you have two numbers and you have to decide if the first or the second is the smallest. If I 10 and 50, you say the first, because 10 is less than 15. And if I give you 15 and 10, which is smaller, the first or the second?
Second.
Okay. So what is the deal? How we will declare this thing? We have to decide. I will propose this way. We will make a function, and remember functions, you can think of them like a contract between the user and the function writer. You have two numbers that following can is A and B. You have these two numbers. Then that is the input should be A and B, and we should return the smallest value between A and B. Let's decide this. What will be the name? What will be what is the name of the function? A function that takes two numbers and give you the smallest one. I mean, it can be Goofy, it can be Mickey Mouse, but choose a name.
It could be find the smallest, maybe.
Okay, that is a nice name. You have to find a name. The point is this, finding good names, it's harder than you believe. We tend to or finding a name, but when you have to find different names every time and be coherent and be able to understand. So let's say, what do we say? Find, no, it will be R code. So find, I want to put it, find smallest of two. Okay, this will be a function. Do you agree with that? No, function is the keyword here. Okay, now what will be the inputs?
A and B.
Okay. Yeah, I choose A and B, but you can say X and Y, or you can say Tom and Jerry or whatever. We need to say what is the output. What will be the output? Well, this is easy. I will give you a suggestion. I mean, for what we're doing, the best option, the simpler option is the option will be called answer. So we will return. Let me even be more lazy. I call it answer or answer. So there will be an answer, and we return that answer. Okay. It's not the only way to do it, but I think it's the simplest that you just in the last point you explicitly say that you are returning answer. Later you can do it in a shorter way, but for now let's do that. Okay, question. What are the steps?
We can make a if else and say that if A is bigger than B, return A and assign that to answer. Should I write it?
Yes, sir. Yes, lady. Yes, ma'am.
Okay. Should I write it in English or like a code? Because I
English.
forgot how.
English.
Maybe something like this, but
Okay.
it could be the other way around. B could be bigger than A.
Yeah, and then what will happen if B is bigger than A?
It should return B.
Okay, you have to say that.
something like this, maybe.
Okay. Anybody has a different opinion? Or let's say in a positive way. Everybody agree? You can say yes, you can say no. It's
I agree.
Yes, I agree too.
Good. Good. If anybody has a disagreement, speak now because we are going to translate. Now we translate this to code. In fact, I have the slide here. Let's go back to the slide. If R is smaller, I say smaller instead of greater, but you see the logic is the same, no? That's the second point. Do you agree that we don't need to say greater or bigger? We can say smaller. It's the same logic, no?
I wanted to say that I like Bruce's idea, but I think we should open up the part where the else is.
Yes. What do you mean open up?
Oh, I think you cleared up everything. We should say, like, the first thing that we said with the A, we should write the same thing but with the B, because like I thought that it can be confusing for the computer.
Well, the computer gets less confused than humans, let's say. The computer can only make one decision. But we should be clear that we are making. So here we have one option, is that the A is bigger than B, and then we should return the first because it's the, sorry, there is a problem here. And everybody says we're trying to find the smallest, and if A is bigger than B, then A is the largest, not the smallest. So let's say, you see my point, that we are finding the smallest, not the biggest. So we were doing it backward.
Confused there.
Yeah.
Sorry.
Yeah, no, I mean that happened. That is why we have to do it in English first to make sure that we understand what we are saying. But I want to follow what is Farida thinking. This, do you think that we're missing something here?
I get what Farida means. When we say then return A, it could not be A. Then we should say else B, else return B.
Else return B.
That's missing.
Yeah. Which is kind of saying the same thing as here. I think that you are right, and I want to make a combination of these two things, because let me show you my slide, how I solved it. If A is smaller than B, then the answer is A. Do you agree with that, no? And here I have two ways of saying. I say else, which is the opposite case. If A is not smaller than B, in fact, I put here, A is greater than B. I put in parentheses, because if the first condition is false, then the second is true, okay? If A is not smaller than B, then A is greater than B. Everybody agree that if A is not smaller, then A is bigger?
Yes.
No? No, they can be equal.
Oh, right.
There was an Excel condition. But if they are equal, you don't care, because they are equal. So if you return any of them, it's going to be the smallest. If I give you 5 and 5, what is the smallest? 5. There's only one option. So you see there are details. So I think there is a couple of lessons here. One is that the details can be important. That is, it is very easy to get an idea that is 90% correct, but you have to be careful with the details. Now, to be honest, my strategy in general is to do, let's say, an experimental method. When I have a general idea, I start with that idea that is 90% correct, and I test it. And I see when it is failing, and then I correct. So your approach is not bad. You go with your first idea and you test it, and you will find that it works sometimes and maybe not in sometimes, and then you fix it. So you go approximating, okay? It's like, when people, let's say Michelangelo is making a sculpture, it doesn't finish it immediately. You start from outside and you make a rough version, and then you polish until you get a beautiful figure. But you don't make the final product in one step. And the second point is the point of Farida, if I understood. Her point is like, we should be clear. We should not confuse the computer. So I will add, we should not confuse ourselves. The computer will do whatever we say. And the problem usually is that we don't say what we want to say. And again, my point is try. In general, unless you are very crazy, whatever you do in the computer is not going to break anything. It's not going to burn or waste. I mean, the worst thing that you waste is your time. But it's not like if you are in the lab, in the wet lab, and you do something bad, you have to throw everything and start again, and you lose a lot of money. If you are doing, I don't know, painting, and you paint it wrong, you have to start again. In computers, kind of experimenting is free. And that is kind of one of the advantages of this and why everybody is doing software today. So how will we do a complete code? Can you try to make the complete function?
We use else one time, or can we use it more than once?
Good question. Technically, if it's not true, it's false. So there is not another option. But what probably you want to say is that you can say, if this is true, you do something else. If you have another if in the second else, you can do that. You can do. Let me give you, like, you could have said, I will, yeah. Let's not write in the same place, but fine. Just to give an example, but you can say something like if, let's say, A less than B, not this A. You do something. And don't forget the curly braces. You can say else if some other condition, let's say A equal B, to do something else. Maybe it would be nicer if we put them in a separate line and with some tab to see. There is, again, a tradition, a good practice that everything that go inside the block, you put a tab to make it clear that it's inside. Okay? And then you can have another else if, let's say, A is greater than B, we do even some, even, not either, even something else. And then finally, you can have a final else. We should never get here. Something like that. Yeah, that can be. In general, you have question like it is true or it is false. But in the case of false, you can still kind of open the question in a second part. No, that will be
in there was a code in the paper I read. Is it correct?
This one that is here. This one, okay. If A, okay, there is two errors here. First, this is not one equal, it should be two equal. Remember, to compare things, you need equal 2 times, okay? Yeah. One equal is an assignment, two equal is a comparison. One equal is an order, make A equal to B. Two equals is a question, are they equal? And the answer they are equal is not following the contract. Remember, the contract says that we return one number. They are equal is not a number. You return A or B. I mean, you return a number. Well, the smallest value. And if they are equal, you return. I mean, you are making it again too complicated. The basic code is here. I'm just asking you to do the extra part. The extra part is to make the function, to make it. This is not a function. If you see, there's nothing called function here. There's no return. There's no input. There's no output. There's no name. So complete the function. And remember, I strongly recommend you to put tab here, so you can see what is inside. Okay, this is interesting because you put an if inside an if, which is a common technique, and you correctly put the parentheses inside the parentheses. You see here that I put the tab, you can see that this is one and this is something completely wrapped inside the second else. Yeah, this is also correct, but I think it is clear if you put the else immediately after the parentheses. So it's very clear what are you parenthesing here. Finish minus 2, function A, B, if A is this, and then, that works well for me. That is. If I had to do something, I would do this. I will copy the English version, and I will put it here as a comment with the hash sign. Everything after the hash is a comment. It's not seen by the computer, it's for the human. So if I am putting in English here, maybe even let's make it here. So explaining in human what you are doing. And the second part was this one. So this way, when you read it, or when someone else read it, you can understand what is happening. Try to combine the human with the computer language. It can be here, or it can be, well, I don't know what is easier to understand. Maybe you should put in the other line. Okay, maybe. Here is a matter of taste, there is not a fixed rule of where to put these things. I mean, probably there is, you know, in places like Google and so, they have a book that say that fix the rules of where to put the comment and this thing, so everybody can understand what is happening. Yeah, here this was not very good because I want to put it kind of here. Something like this.
I have a question.
Go ahead.
We read that is A smaller than B code, but if we say A smaller and equal to B, in this way, it gives answer. If it's equal, it's just say 1. Like we say 5 and 5, it's just say 5.
Yeah, I mean, the code works because if A is equal to B, any of them is going to be the smallest one. There is no error on that. I am just changing the comment for the human, but for the computer point of view, they work perfectly. They give you the correct answer in every case.
Okay.
So basically, the point that we have is how we get the correct answer on every case, and how to, because let me put it in a scientific context. When I asked you in the quiz, well, not this one, but when I asked you in the quiz, why we have the different sign in the GCSQ. You remember that last week I did the GCSQ gene by gene and I didn't get any change of sign. So maybe I made a mistake in my program. So that is the first question that I make. Maybe I made it wrong. Maybe I made it wrong, or well, let me say this way, in an even more optimistic way. Turn off my camera. Turn the camera. Come, camera. Come, wake up. No, didn't come back. I don't know what happened with my camera. Anyway, the basic point that I want to make is that when you do an experiment, you have something that you expect to see. If you don't see what you expect to see, it is either you make a big mistake or you make a big discovery. Of course, you want to be the big discovery, but you have to make sure that you don't make a big mistake. That is why it's important that you check that every one of your tools is doing the correct thing. And in this case, the tool that we're using is the computer. The same way that you want to make that your pipette is giving you the correct concentration of stuff, and every step in your experiment, you should make sure that you are doing what you are supposed to do. In the part that you use the computer, it's the same. Okay? Now, what else we have? Another exercise. Smaller of 3. What will be now? What do you think is the rule for a smaller of 3?
We could add another input, but I feel like there is going to be more than 3 in the way.
Yeah, but this is not. Yeah, in the future, I agree with you. In the future, it will be that you are saying that is the next exercise is do it for n.
Yes.
But let's do for 3 first.
We learned floor function in the first.
Okay.
Maybe it can be. We can use this.
How will you use that? Floor function, if you don't remember, it's like you take a number with decimal and you drop the decimals and you get the integer part, no? Is that the one that you are thinking?
Yes.
So if these are integer numbers, they don't change.
Yes.
And if they are not, you are changing them and you are losing the original number. So yeah, I don't see, but okay. I mean, I value being creative, but this is not really a creative thing. This is if you like, a very toy problem. But I'm going from the beginning so you can practice when the thing gets harder. Let me say that when I give this as homework in the last year, people could not do the homework. Okay. Okay.
Can't we use the min function? Maybe?
No, because no, come on, that is the trick that we're trying to make our own min function. Can we cheat and do like I'm making make your own DNA polymerase, for example. Make your own DNA polymerase. I can buy DNA polymerase. I don't know. Make your own yogurt. Easy. I go to the corner, I buy yogurt, and I get yogurt. No, you have to make your own yogurt from zero. Make your own bread. No, you don't buy bread when you are trying to make bread. We are going here from zero. Water, powder, flour. We are making bread, okay? Not buying bread.
I wrote something from chat and I checked it works.
Okay, and maybe you can put answer -1. What? It's matter of 2. Why answer -1? Why?
Because we want to use firstly smallest value, then smaller of smallest value.
No.
Right?
No, good question, because I appreciate your question because it shows what I was afraid that the first step is to understand the question. It's usually the 90% of the problem, or 60% of the problem is understanding the question. We are not looking for a value that is smaller than the smallest of them. We are not looking for a value that is smaller than all of them. We are in this question is given 2 numbers, which is the small of them. If I give you 10 and 15, you are giving me 9. If I give you 10 and 15, you should tell me that 10 is smaller than 15. You should tell, I give you 2 numbers and you tell me which is the smallest one. I say you 10, 15, you should tell me 10. In your code, you are saying 10 and 15, and you give me 9. And 9 is not 10. The answer should be either A or B, nothing else. We are not making a new number. And that is a good point, because the smallest value between A and B. Okay, maybe the point is that the English is not very clear. And that is a valid point. That's a valid point, that maybe the question is not clear and you have to make sure that you are answering the correct question. That happens a lot. That happened that, and I mean, it happened to me that I make an exam and then I check the exam and the exam is not what I really want to say. And when you are doing your own research, it usually happens that you ask the wrong question, or you don't understand the question, or you answer a different question. That is super common. So that's kind of in the long perspective of this course, what we want to emphasize is that we should take a moment to understand what are we really saying. When you see, I don't know, discussion about health or discussion about science or things like that, that people kind of don't understand the real question. No? I mean, the people who doesn't like to vaccinate because vaccines are artificial and everything artificial is bad and everything natural is good. This kind of thing that people don't understand the question. Here, I agree with you that it's not said. It's not said, because I just say the smallest value between, maybe the keyword here is between A and B. Yeah, one way you can think like there's something in between, but maybe I should say among. But the basic point is that you enter with A and B and you give one of them, not a new number. So the learning is that the question is not a good question. It should be more explicit. You enter A and B and you give one of them, either A or B. So let's be clear, the answer should be one of these things. And so in other words, your code, the only problem is that you are answering, you are returning answer -1. If you return just answer, your code is correct. The -1 is the problem here. I mean, I assume that everybody is looking. Let me do something. Just for the record, I'm going to copy this in the chat, in the document. So we can, if you're for any reason not looking at the chat, this is the code. And of course, this part doesn't count. This is a trick of the copy and paste. So what Zainab did here was the correct answer to a different question. It's not wrong, it's just that the question is different. What she's given is a number that is smaller than all of them, but it's not the smaller of two of them. It is smaller than two of them. So human language have this ambiguity. And the computer language cannot be so ambiguous. You have to be, I mean, the computer is very silly. Remember, the computer cannot understand anything. So if you want to tell the computer what to do, you have to say explicitly. And in this case, we have to be clear. So what we have here. In this second question is this: you have 3 numbers and you find, you return which of these 3 is the smallest. But only, it can be either A or B or C. Okay? Fine? Okay, go. Hand raise.
I have a question. Can
Go
you
ahead.
ask in functions? Ask command in functions?
I don't understand.
We say if and as, but we can use function and as. Can we use it?
No, function, no. Else is
For
function
if.
is also another part. If the else is part of the if. the if command, the if keyword has two versions. One is only an if, and the other is if and else. They go together. You don't have else. You cannot have an else if you don't have an if, because the else is the opposite of something.
I got it.
Now, what you can do is you can put an if inside a function. But the if and the else go together.
Okay.
It's a North Pole and South Pole. They cannot be separated, let's say.
Actually, I have a question.
Go ahead.
I didn't understand that this part. Why we use return answer -1?
We don't use that. Was the NE proposal because she made this proposal. Let me put here. This is not the correct answer. But let's be clear. It is better to have a wrong answer than to have no answer. Because you do it, you test it, and you learn from it, and then you fix it. Okay? I personally make this mistake of putting +1 and -1 a lot of time, but then I correct it. So I much prefer something that is 90% the correct answer, or let's say this is the correct answer to 90% of the question. Okay. So I don't be afraid of making mistakes. We are here to make mistakes. It's called experimental method. Don't be afraid of making mistakes. Don't be afraid to ask questions. There is no stupid question, except the question that you didn't ask. So I really appreciate that we are seeing what are the weaknesses of our language. You know, when we say it kind of very cool, very easy, we say something that is not very clear. And you get people speaking about different things and they don't know that they are speaking about different things. So what will be, okay, let's are we clear now? No, we have 3 letters, 3 values, 3 numbers. We're assuming that they are numbers, okay? Maybe they are not, but let's assume that they are numbers. That's part of the contract, that we only give numbers. That is the contract. The function will receive 3 numbers, not 4, not 2, 3. Okay. And we must return 1 number, and should be chosen between these 2, 3, and the condition it should be smaller than the other 2. Okay. So you know the drill. What is the name? What is the input? What is the output? What is the code? The 3 first, okay, the second and the third are very easy. The name, you have to be a little more creative, but it's not very hard. It's like find the smallest of 3. Okay, if we follow the same logic as before. What is the code? Anybody want to give a comment here? Okay, tell me again. What is the name? Okay, perfect. Okay, very good, very good. So it's a very good idea to start from the previous one. That is again a good strategy. You know something similar. You start with something that is similar. Smaller of 3. Good name. Function ABC. The input. Return the answer. Good. This is very good. Except that we have the name, we have the input, we have the output, but we don't have still the code, because here, what is missing in this part?
C. There is C.
C, exactly. C. Okay, I am turning my camera off because I want to see the code here.
I did something, but I kind of work for the computer. I'm gonna paste it right now.
Okay, but I think for exploring ideas is not a bad approach, and in fact.
I mean, it works. I tested.
Well, we have to see how you test it. Okay, you have to test it several times. Interesting. So let's say that you have 10, 15, 20, or let's say 1, 2, 3, 1, 2, 3. Okay, so if 1 is less than B, okay. If 1 is less than B, the answer is 1. Okay, then, well, if you got on else, you know that B is greater than A, and you can say B. You don't need to do that thing. Then, but the point is this: if A is less than B, you get A, and nothing else is executed, and you go directly here, and you return 1. So if I give you this, I give you 2, 3, and 1. So you compare 2 and 3, and you find that 2 is the smallest, and then you go directly and you answer. You answer 2 and not 1. You see? Because if this is true, nothing else is tested. So if this is a number 2, and this is a number 3, and this is a number 1, you never see C. So you have to guarantee it. So, okay. Good approach. But it's fine. I mean, don't expect to get the answer in the first moment. There is something, if you like, in the human nature here that people don't want to make mistakes, but we are human. And as far as we know, humans make mistakes. So you should be comfortable with that. We should be comfortable with failure. Especially since you are going to be scientists, and science is the process of failure. In science, the only thing that can happen is that experiments fail until they fail failing. That is what we call success, when they fail to fail. Experiments are going to fail most of the time. And if you are not comfortable with that, you are in the wrong business. You should be comfortable with failure because it's the way we learn. If you see, the philosophy of science is of you have a theory and then you prove that the theory is wrong. The only thing that you can do in science is to prove theory is wrong. So you have to make a new theory. That is how science advances. Destroying the old theory. Scientific method 101.
I wrote something. Can you swipe up
the
paper?
Where? This one? No.
No, swipe down.
Down. You say up, that's down. Okay.
But
even down.
Failed because
here, this one.
Yes.
Okay.
It doesn't work.
It doesn't work because you cannot compare things, but it's a good philosophy also. It's kind of, if you write it in English, it probably makes sense. But you cannot make this comparison. Like, let's say the point is this: you have to say that you are saying that A is less than B and B is less than C. Maybe you can write this. No, you can say this and B is less than C. That will be a way that it works. It works in the sense that the computer will take it. And you translated your English to computer language, and that at least it matches the logic of the computer. But do we have any other option? No, it probably works. It probably works because I mean you are essentially saying what is. But I don't see how we are going to make it general. But yeah, this is probably a good answer for the question that we ask. Seems like a valid question for the question that was asked.
I write a code in chat.
Well, please write it here because not everybody will see the chat and particularly will not stay in the video. So,
okay.
Please. So, what I'm doing here, I'm hiding this thing. Someone came and didn't say anything and went out. This one, okay. A plus B and B plus C. Oh my gosh, and what happens if they are negative numbers? Okay, if A plus B is less than B, then C, essentially you have an inequality and you can cancel B. You are essentially saying that A is less than C. Because you are adding the same number in both sides of the sign, so you can drop this one and this one. If A is less than C, then you compare, okay, and this is not obvious here, because if A is less than C, and A is less than B, then A is the less one, the smallest one. That is fine here. But if A is not less than B, then you have to compare B and C. It may be that A is less than C. For example, let's say that you have 2, 1, 3. So 2 is less than 3, you got here. 2 is less than 1, no. And and you get maybe I'm. Can it be that C? Yeah. What if you have 2? The A is 2, B is 4, and C is 3. 2, 4, 3. So A is less than 3. Then 2 is less than 3, 2 is less than 4. Sorry, what I say? 2. I say 3. What did I say? I want C to be the smallest. So this is 3, 4. No. I want B to be the small. No, what I want. Can it be that A is less than C, but B is bigger than C? Yeah, it can be. But if A is, okay, anyway, I think there is a condition that doesn't work here, because here, what you know here is that A is less than A and B, but you don't know if B is less than C or not.
What if we delete the blue part? Will it be true?
Yeah, probably. Except that you have an if here, and you don't need to happen. What if C is smaller than A? You have to find. I have another proposal. Let me give you this proposal. And you are kind of following the idea, but you know how to compare two numbers. So we can compare A and B and find the smallest one. And we solve that problem. And we forget about A and B, and we got the smallest one. I'm trying to decompose. Remember, the strategy here is decompose. A and B. Okay? And when you found the smallest of A and B, let's call this answer, okay? Then you compare this answer to C and find the smallest of them. I'm trying to decompose in two parts, comparing the first two, and then when you find the smallest of the first two, you compare that with the last one, okay? So what I'm going to do is going to take this answer. No, this one. Okay, let's go. I'm going to copy and paste lazily. This is not the only way to do it, by the way. Yeah? It's not the one. This kind of question may have more than one answer, but I think it's a way that can be easier to deal later. Let's take this code. This part is not bad. The return was the problem, but we are not going to return yet. So here, if A, I want to put it a little bit like here. No, not too much. Okay, let's put if A is less than B, then the answer is A. Okay. Otherwise, else. I don't know the difference between otherwise and else, but I remember when I was in the PhD, I had an English teacher, and I say else, and he say no, you don't say else, you say otherwise. I don't know why, but I learned to say otherwise instead of else. I mean, I was British, so. Okay, so in this at this level, here one hash. What do we know here? Here ans where, let's put in quotation marks so we know it's the variable called answer, has the smallest value of A and B. A and B. These are also variables, so I am putting. Okay. So we need to do the same trick again, comparing two things. Okay, the logic is the same, so I'm going to copy the code here. Except that what are we going to compare here?
The answer and the C, right?
Exactly. Isn't so? Answer, if answer that we have here is less than B, less than C, then the answer is answer. Else, answer is C. Yeah. Okay, this is a kind of funny code, but I want to raise questions here. I want that people ask. There is no stupid question. Okay, question that you don't ask. Okay. Yes, no? So there is something silly here, but I hope you find the point here. First, do you see the logic here? That I decompose the problem in two parts. I make the first two 1 to 5. I mean, this is like the World Cup, you know, or the tennis. You have the two tennis players competing, and one wins, and that the one that wins go to the next level. Okay. You know when they play in pairs, and then one lose go out, and the winner go one up. And you compete in the second round, you have only the winners, and you drop half, and only the winners. You go dropping half in every step. Yes, no? I don't know. I don't know tennis, but what do you think? say something. The question is this: do you understand the logic here of separating the problem in two smaller parts, comparing the first two and then comparing the second two? I mean, the result of the first against the next one?
Yes.
Yes.
Second, this part is silly, no? We don't need to do anything here. I mean, assigning the number to itself, you are not updating, that you don't need to do anything.
Should we use answer 1 and answer 2?
It is a good question. It is a good question. It can be. That could have been an option. But if you look carefully, you don't need to do that. And I will not like to do that because remember that the values can be updated. You have the variable answer is, if you like, a temporary answer. Here, let's say, let me put it, we'll put a comment here. Here we update, I'm putting with letter, the value of answer. If you remember, in the last week quiz, I'm going to put this very clear so everybody understands what we are doing here. I say A equal 2, B equal A equal 5. So I updated A, and that doesn't update B. You remember that in the quiz, no? And then I asked A equal A plus B. You remember that? Okay, if you don't remember, okay. Everybody, somebody doesn't remember? The people who don't have camera, they have to speak. I know that, but in particular, well, Farida already spoke, so I know that she's there. And the other, I want to know if Dilem is there and Kubra is there, because if you don't show your face, I don't know if you are looking. Okay. If you don't want to speak, turn on your camera and move your head.
We are here.
Good.
I'm still listening. Yes.
Good. Speak. It showed that it's okay. So did you do the quiz last week? No, you didn't. So
No.
I did this thing. I say A equal 2. Then we say B equal A. So at that moment, B takes the value of A. Then we say A equal 5. And you have to know that B has the value of 2, but it's not connected to A. It's a copy of the same value. So B is still 2, and A is equal to 5. And then I say A equal A plus B. And that is essentially 5 plus 2. And that get assigned. So at the end, A equal 5. At the end, A is 5. No, 7. 5 plus 2 is 7. Okay. So the values can be updated. And here the point is that here we have a temporary answer. And that is the idea that people had trouble in the previous semester. This is a temporary for the time. When I say temporary, what, do we have any better word to say? Temporary. A draft, if you like, okay? An approximation. So we cannot tell for sure because we have not yet seen everything, but it's so far what we know, okay? Like, I don't know, let's say that you are going to see, you are walking by the street and you are, let's say, looking for the cheapest, I don't know, what are you looking for? The cheapest cement. There are many people selling cement and you want to see who has the cheapest cement in all the streets. And so you see on the first, the guy say that 2 liras. Okay, it's the only one that you have seen, you don't know better. Then you keep going and you see one that's 175. That is better. Then you see another that say 3 liras. No, that is not good. Then you keep going and you know that the best was 175. And then you want to find something that say 150. And you have the right to update the best one as you get more information. The more you see, the better you can choose, no? There is, in fact, a famous thing like you are trying to hire someone. You are interviewing 10 people, let's say. So you interview the first person and you get an idea, and then you interview the next one. If the next one is better, you keep the next one. Otherwise, you keep the first. And you keep interviewing, and at the end, you choose the best of all of them. The more you know, the better. So you have the idea that you can be updating. So let's make a cleaner version of this thing. Okay, I want to make a clean version. Any question? No stupid question. Yeah, no, maybe, sometimes.
I have a question.
Okay.
Can we do this? We say A plus B plus C and have a D, and we should compare all of them with D. If one of them is smaller than D,
what happens if I give you 1 million numbers and you want to find the smallest? Are you going to sum 1 million values?
We should sum of all of them, and then divide the
what is the reason, the relationship between the sum of number and the smallest of numbers? Why you make your life harder? Try to make it simpler. Try to make it simpler. Some are not going to help you. When you sum two things, you lose information. You have, I mean, let's say the sum is 10. What are the two numbers?
4 and 6.
Or 1 million and minus 1,000,010. I don't know. Or something like that. You don't know. You don't know, can be anything. So the sum is giving you less information than each one of them. Okay, let's make a simpler version here. If answer is less than C, answer is answer, so we don't win anything. So we can just drop this line. We do nothing. And if we are doing nothing, what I will do is revert this question. If answer is bigger, okay, let's make it the other way. Let's say if C is smaller than answer, more clear, then the answer is C. Okay? No, I mean, you can try if you want to do something with sums, but honestly, I don't think it will go to any place because you lose information when you sum. And it's very straight. I mean, when you go buying the cheapest CMIT, you don't sum things. You don't take average things. You say, okay, this is bigger or smaller.
But I said just for 3 numbers, not 4 or 5, because if it's
but when you choose, you have 3 people selling you CMIT. Do you sum the price of all the CMIT and you compare each one with the sum divided by? No. You compare the first 2 and you choose between the first 2, and then you compare with the other one. Otherwise, you die. You don't eat anything and you die of hunger. It takes too much time to. It's a simple question. Which one of the, like I gave you, which one you like better, this or this? You can answer that question. One will be favorite, and then and this or this. Well, you already knew for 2, and you can compare the new one. You can either keep the old one or improve with the new one. And I give you another one. Do you like this better? Yes or no? Well, you already solved it for. There is a pattern here that solving for 3 is solving for 4 is solving for 3, and then solving for the last one. Solving for 3 is solving for 2, and then adding a new one. Solving for 2 is that they can do directly. There is a pattern. Interesting. Okay, here I made a simplification. Now let me give you another simplification here, which is this. We can start assuming that the answer is A. And then if B is less than A, to avoid this, I am trying to avoid this else, less than answer, this is a temporary answer again. So we have temporary answer until we run out of time and until the end. We start. Okay. Which of all these pens you like better? What is your favorite of all this one?
Just one.
There is no option. If you have only one number, you already know the best one. If there is only one option, you know what is the best option. Okay, so this is the best so far. Then you get another. You can decide of these two which you either keep this one or you replace by this one. Okay, let's say that we replace, we drop it. You take a new one. You like it better? No, drop it. This one, you like it better? Yes, drop this one. This one, you like it better? No. This one, you like it better? Yeah, sure, blue. And so on, until you finish. Oh, there are no more. This is the best one. I will start with the first one. And if the second is better, then we update. And if the third is better, then it. And then we return the part that is missing here. Return answer. So the idea here is, first, you decompose the problem in two parts. First, solving for the first two, and then solving for the next one. If you like, even decomposing even more, start with one. If you have only one, decision is very easy. You don't have any decision. It's the best one. Then you get a new one, and then you can update your opinion. You get new data. You can have another option. Okay. And then you get another, and then you get another. So this is going to be the exercise now. Smallest of many. You get a vector, x, many numbers. We don't know how many, but n numbers. Can be 1, can be 3, 1 million. Give me the smallest. That is your exercise, and we can do that during the break.
Smallest of many.
The smallest of many, perfect name. I will find the smallest of many because but this is a personal opinion. This is not always a rule, but functions are verbs. They do something. They find the smallest. It's not the smallest value, it's the function to find the smallest value, and the result will be the smallest value. It's like, I mean, cooking, making bread is not bread. Okay? Cooking food is not food. The kitchen is not food, let's say. What are the inputs?
We can say X.
Yeah.
And then we use supply, and then.
Not necessarily supply, but maybe. I will. The point of supply. Remember that supply only works when the order of elements is not important. But here you have to test one first, and then compare that result with the next one. So let me show here. Here there is an order that we test one, and then here we take the answer of the previous one, and here we take the answer of the previous one, and here we take the answer of the previous one. So supply is not necessarily going to work here. This is the case that when you need the for loop. Remember that we say that supply is very good, except if you depend on the previous result. Because supply doesn't. Supply, the idea of supply is that you are going to do it in parallel. You have a supercomputer with a lot of processors, they all go in parallel because they are independent and you don't care about the order. But here, the order is important. This is first. I mean, whatever order. You can change the order, but there should be an order. They cannot be done in parallel. Okay?
Okay.
So, I think I follow. But okay, what are the input? X, the vector X. That's the only thing that. What is the output? One number, ans. Okay? So what I'm saying that this, first we need a function name. And we say something like, find the smallest of many. So any answer should be something like this. Smallest of many. Okay. And the input is X. So if you take a code like this, you are in trouble because you are overwriting X. And I will tell you a rule here that the input of the function are sacred, are holy. You don't touch them. You don't do anything with them. You keep them because if you lose them, no way you can recover them. It's the part that you cannot replace. You can calculate everything except the input. That is the part that you don't know. I mean, technically you can modify it, but you have to be careful because, again, you cannot go back. You have to be careful with that. So let's say you have to treat like a newborn baby. If you break it, you will not repair it, let's say. So maybe the answer will be something like, but then there is another point that caught my attention here. You're saying answers to I. That essentially means that answer is a vector. So maybe that is why you're thinking of this rep thing. But if you remember the question, we are looking for one single smallest value. So the answer is not a vector, or if you like, the answer is a vector of size 1. What is C here?
C is a vector.
And where did you got it?
I will write it right now.
And why is C sub X? What is X sub X? What if X is a vector with negative numbers? But what if I want to test for other numbers? You have a confusion. Remember that X, you don't know X. Someone is going to tell you later. Ah, I see. Okay. I see who is if.
But I couldn't find output. I used
Yeah.
output, but it not work.
What if you start with the solution that we had before? This X can be negative number, can be 0, and you cannot have 0 as an index. So it will break at the first test that I do. I will test with 0, and it will give you an error. And then why these numbers? How did you get 109? You are using this for your function. Why? If you choose a fixed number, there should be a reason. Okay. Don't worry. This is homework. So you can have time to think it. You will have 1 week to think it. But you see, I mean, the thing that always surprised me is that people have a hard problem explaining how they buy cement in the street. How you choose, I mean, the job. You want to find a good job. How you choose a good job? You see the first one. If you like it, you take it. If you don't like it, you look for another one. I mean, how you know that you like it? You got one job and then someone came with an offer of a new job. Let's say that you work somewhere and every day someone is offering you a new job. You have to decide, shall I keep it or shall I change to a new job? How do you decide? Let's say the payment, let's say the work is the same, just that they pay you more. How you decide? So every day you decide, okay, should I stay in this job or should I go to a new job? And you do it every day until, I don't know, you retire. It's the way that we do it every day. I mean, you solve this problem several times every day. What you watch on TV? You have, I don't know, 100 channels. What you will see? The best movie. Okay, how you know what is the best movie? You have to see at least all of them, maybe read all of them, maybe you have Netflix and you read all of them, and how you know which is the one that you like more to see now? It's a real problem that you do every day. And I'm making it simpler because comparing movies is a harder question. But here I am assuming that the simple way that you have numbers. By the way, numbers, maybe they are not integers, so this subindex, I don't know, you have pi, if x is pi. It's a vector that contains several numbers. A numeric vector, in other words. Okay. Can I choose it randomly, x, these numbers? Can I choose any number? Okay, I will choose my numbers. My number will be this is small. Just can't say that I can use anything, so I will choose 3.14156 and 92. If that's what I remember. And can it be an imaginary number? Okay, this is my vector. And then I use find the smallest number of 1, 2, 3. Remember, x is your input. And the answer should be any of. The point is the problem is of this logic is this. X is the input, and the answer should be one of the element of x. Let me say that I will take x equal to the vector 1, 2, 3. So the answer is either 1 or 2 or 3. And in your function, the answer will be either p or square root of 2. And I will make it harder. 1.5 minus 2, 3.33. So when I use x as an index, it will go crazy. So you cannot depend on something external. You have to decide. This, on the other side, solve it for 3. You can extend it to make it for 4, for 5, for 6, for 60, for 600, for n, for 1 million. You have to just to make this general. So you don't, I mean, let me give you a, trying to be clever, trying to find a super solution that nobody think before usually fails. I spent many exams of my life trying to have a clever solution for simple problems. This is a very straightforward problem, and it's a very real one because you do it every day, and it's an easy one. So you should not think that you do complicated way. Just think, make an introspection. Ask yourself how I do choose things in life, how I know what I like most. Okay, that is, I think, homework 4.